Have you ever wondered how companies can predict their future sales? Or, how economists forecast market trends? Well, a lot of the time they use a surprisingly simple but really powerful tool to find patterns in past data. Today, we are going to break down exactly how that works. We're talking about forecasting with regression.
So this is the big question, right? When you've got all this historical data, maybe from last week, last month, or even the last few years, how do you turn that history into a solid prediction about what's going to happen next? Let's dive in and find out.
Okay, first things first. We need to talk about the kind of data we're dealing with. It's called a time series. And all that means is it's a bunch of information collected over time. Think about it like monthly sales figures, daily stock prices, or even the temperature recorded every single hour. It's basically data that has a timestamp on it.
So, how do we take that time series data and actually make a prediction? Well, we use a brilliant and honestly pretty straightforward tool called linear regression. This is going to be our key to unlocking what the future might hold.
At its heart, the idea behind linear regression is incredibly simple. You just take all your past data points, you plot them out on a graph, and then you try to draw a single straight line that best fits the overall trend of that data. That's pretty much it.
Now, of course, that line isn't just drawn randomly. It's actually defined by a very famous, very simple mathematical equation. You might have seen it back in school as y equals mx plus c, but in this context, we'll usually say y equals a plus b times x. Don't worry, it's the exact same idea, just with slightly different letters.
Let's just quickly break this down so it makes perfect sense. Y, that's the future value we're trying to predict, like next quarter's sales. X is just our time variable, so the month, the year, the day, whatever it is. A is what we call the intercept, which is really just the starting point of our line. And B, the slope, well, that's the most important part for us. It tells us the trend. Is it going up? Is it going down? And by how much?
So, why even bother with all this? Well, there are three huge reasons. First, it helps you spot a trend almost instantly. Are your sales generally climbing or falling? Second, and this is the main reason, it lets you forecast future values. And third, it's just a beautifully simple and easy to understand method, which makes it the perfect place to start with forecasting.
All right, theory is one thing, but let's make this totally real. We're going to walk through a super simple, step-by-step example of predicting future sales. I promise this is where it's all going to click. Every single forecasting journey starts at the exact same place. You've got to collect your data. You need that history to find the pattern.
Okay, for our example, we're using this really clean data set just so the concept is crystal clear. So at time 1, let's say our first month, we made 10 sales. At time 2, 20 sales, time 3, 30 sales, and so on. Now, in the real world, data is never this perfect, but this simple example really helps us see that straight line relationship we're looking for.
Okay, we've got our data. Step 2 is all about finding that one single straight line that best fits these points. Now, best fit actually has a real mathematical meaning. Computers use a method called least squares to draw a line that gets as close as possible to all the data points at once. The whole goal is to make the gaps, or the errors, as small as possible.
So for our nice clean sales data, the math spits out this equation. Y equals 0 plus 10x. The intercept, A, is 0. That just means our line starts right at the beginning, at the origin. The slope, B, is 10. And this tells us something really cool. For every 1 unit of time that passes, our sales go up by 10 units. It perfectly describes the trend.
And now for the moment we've been waiting for. We get to use the equation we just found to do what we set out to do in the first place, predict the future.
So this is where it all comes together. If we want to know the sales for the next time period, for time equals 5, what do you think the answer will be? All you have to do is plug the number 5 into our equation, right where the x is.
Yep, you got it. It's 50. Y equals 0 plus 10 times 5, which gives us 50. Our model predicts that in the 5th month, we're going to have 50 sales. See how powerful that is? We just use data from the past to make a really specific guess about the future.
Now, this tool is awesome, but it is not a magic crystal ball. And for any exam, it is absolutely critical to know not just how a tool works, but also when it doesn't work. So let's talk about its limitations.
So, linear regression is an absolute champion when your data shows a clear, straight-line trend, either steadily going up or steadily going down. But it really struggles with more complicated patterns. For example, if your data has seasonal peaks and valleys, like ice cream sales that spike in the summer, or if it has sudden, irregular changes, a simple straight line just isn't going to capture that reality very well.
All right, this is it. Let's pull everything we've just learned together into the perfect, concise answer that you can use to absolutely ace that exam question on linear regression.
Let's look at what a great exam answer looks like. You want to start with a clear definition. It's a method for analyzing data over time. You have to include the equation, y equals a plus bx. Then you state its purpose, forecasting and finding trends. And here's the key to getting top marks. You always mention the limitations, that it only works well for linear patterns and struggles with things like seasonality. Hitting all these points shows you have a complete picture.
And because I know exams can be super stressful, here is a dead simple memory trick to help you remember the key ideas when you're under pressure. Just remember these 3 letters. TLP.
So what does TLP stand for? T is for the time series data we start with. L is for the straight line that we fit to that data, and P is for the prediction we make using that line. Time, line, prediction. Simple as that.
And finally, here is a pro tip that'll make your answer really stand out from the rest. Don't just write about it, show it. For those extra marks, always try to sketch a quick, simple graph with a few points in your best fit line. And of course, always write down the core equation, y equals a plus bx. It proves to the examiner that you really get it, both visually and mathematically. You've got this.